Yes, I'm the NYU student, and I'm going to do the presentation of the Beijing Electron Position Collider, which is also called BEPC. My name is Jiayu Wang, and first we are going to introduce the background of the collider. The collider is a kind of the high energy accelerator. It can accelerate two beams of the high energy particles to very high speed by electromagnetic field, sometimes also the microwave. And then the collider will let the high speed beams collide and break into pieces. The particle physics scientists will do the research and get the data information from those breaking pieces and to get back the identities and characteristics of the particles. Most of the time, the particles are the nucleus, protons, positrons, and electrons. And for the Beijing Electron Positron Collider (BEPC), it has a rough experience. Actually, the start the program started in the 1979, which in that time the director of the High Energy Institute, Yu Wenzhang, he proposed to build 400 gillion electron volts accelerators, but it cost too much, and with the later financial difficulties, the program was cancelled. But in 1980, and the program was restarted, but only with a very low budget. But with hard working and discussion of uh, the scientists and engineers, the the BEPC finally began the construction in 1984 and completed the first colliding in 1988. It has been past 30 years and it has many achievements like the measure the weight of the tau lepton and discover the new particles S1835 and improving the precision of the reaction section of hydrogen creation. Here's a photo for the BEPC, and as we can see here, the very long part is injector, and the rings around here is the storage rings, and there are two synchrotron radiation laboratory in here, and here's the spectrometer. Yeah. So first we do the need analysis. There are two questions. Why did China need to build the collider? Because collider is a very expensive thing, and it's a huge engineering. It requires the high level technology, the high level construction. So and it also has high risk. So why did China need to build this with such a high risk? And the second question is there a feasible method for China to build this huge collider? First, we do the why problem. I concluded three reasons for that problem. First, there are thousands of scientists came back from the abroad and joined the high-tech construction in China. So those scientists are going to devote their energy and figures to the constructions of the collider. And also, with without the accelerator, it's hard for the particle physics to develop in China because for the particle physics is going to doing focus on the macro world, those macro particles like the quarks and protons, neutrons, photons. Oh no, not the photons. Sorry. And without the accelerator, they can the scientists cannot start get the useful information and to do any research. So it's hard for the physics, particle physics developing in China. And the third one is the Chinese scientist has to go to the Soviet Union and to use the accelerator in the Joint Institute for Nuclear Research. It's very far away from China. It's a long trip to those scientists, and also it's very inconvenient to use accelerators in other countries. There are many limitations to Chinese scientists and many unfriendly rules. Here's a photo for the Joint Institute of Nuclear Research. I guess this accelerator has been shut down because it has been replaced by the high energy accelerator. So, next is it feasible for China to build the collider? Firstly, I think because of, like I mentioned before, there are many scientists come from abroad, and among them, there are a group of scientists has the work experience in the accelerator center in different area like in Europe and in United States. They accumulated rich experience in the operation and the series of the high energy accelerator. And also because of the good relationship between China and the Soviet Union, the Soviet Union sent nearly 5,000 specialists in different areas to China. And among them, there are a group of specialists who are working in the particle physics area. So, under the guidance of the Soviet Union specialists, the Chinese scientists designed the 2 GeV electron synchrotron accelerator. Also, the Soviet Union allowed the Chinese scientists working in the JNR, and even later the JNR forced those scientists came back to China because the relationship broke up. But those scientists also accumulated rich experience in the circular accelerator. And the China-US High Energy Joint Commission formed in 1979. This commission is the first China-United States commission in science area, and it meant the American scientists would help the Chinese scientists to build the high energy conjunction. So, next is the concept exploration and definition. Uh, we need to make sure which performance of the accelerator the China need to build and how to pick the best feasible program with lowest cost and best performance. In that time, there are three main kind of accelerators in the world. First one is the fixed target proton accelerator. Second one is the positron electron collider, and third one is the proton collider. For the fixed target proton accelerator, there was a 12 GeV electron volts energy level in high energy accelerator research organization in Japan, and 980 GeV electron volts energy level in Fermi National Accelerator Laboratory in United States, and 400 GeV electron volts energy level in European Organization for Nuclear Research. And for the positron electron collider, there was 8 GeV electron volts energy level in Stanford Linear Accelerator Center in United States, and 10 GeV electron volts energy level, and one with 46 GeV electron volts energy level in German electron synchrotron in German. And here's a photo for the Proton Collider. As we can see, it's a very huge equipment. And there are 62 gigation force energy level in European Organization for Nuclear Research. And since in 1981, the government agreed to restart the accelerator program, but the budget was only 19 million RMB, which is about $30 million. It's a very low budget to the construction of accelerator in that time. So the Chinese scientists has a very fierce debating about the program, how to build a accelerator which can do meaningful research with such a low budget. And finally, they got two programs. First one is a low current slowly extraction, 5 GeV proton synchrotron. And second one is a 2 GeV fast loop enhancer. And then there was a meeting in United States, which has Chinese particle physics scientists and American particle physics scientists to discuss how to build the accelerator. And in the meeting, the WKH Penforsky proposed his program, which is agreed by the Chinese government in the end. His program is to build a 4.4 GeV electron positron collider, and the collider could install the synchrotron radiation device. And it has the high radiation than the synchrotron produced in Hefei Synchrotron Radiation Research Center. And for Penforsky program, the accelerator has four major parts: the injector, storage rings, and laboratory and spectrometer. First is the injector. Uh, it is a long electron positron linear accelerator and formed by 46 S waveguide accelerator tubes, 16 clastrons with 30 million watts max power and high energy fault pulse modulator and 270 kilovolts voltage, 3 ms bandwidth, and it can accelerate the electron beam and to get the electron positron pairs. And for storage ring, it has five subsystems. First is a magnet and a power source, and second is a higher frequency system, and third is a vacuum system, fourth is the injector system, fifth is a control system. And for the spectrometer, it needs the ability to charge the particle and high resolution to momentum and positron, and also the reactivity to low energy photon. For the synchrotron radiation laboratory, there are three channels to eject the synchrotron radiation beam for research from the particle colliding. So the Penforsky compares the two kinds of accelerators, which is the fixed target proton accelerator and the electron positron collider. For the fixed target proton accelerator, it has more secondary radiation, which meant it can do more samples for the analysis and wide range for utilization. But for the electron positron collider, it has high efficiency in energy utilization and lower cost. And also, the collider has fixed energy range. So, in that time, the other countries in the world are focusing on the high energy level collider building, but China can build the 4.4 GeV collider and focusing on the low energy area and do the meaningful research, which is so this is the final reason that it was accepted. And also in 1981, the Fang Yi, the director of the State Science and Technology Commission, accepted the proposed accepted this program, and yeah, agreed to spend 5 years for the construction. And finally, is the challenge. Uh, Even the program has been agreed, there are also challenges in front of the Chinese scientists, like the technology problem, which is the luminance of the collider is much below the required values. So the spectrometer might be hard to capture the particle debris from the cladding. And also during the constructions, the U.S. particle physics scientists might stop offering assistance because the international political environment may be cause China and the United States broke up and stopped the assistance. And only 65 million RMB, which is about 22 million US dollars budget for the electron position collider project is much lower than the original one. Okay, that's all. Thank you.